Hello everyone, I am Chadadev from Honors-A Cohort 10, and today I'll be presenting my project in the 4 IMU Poster Exhibition 2024. Firstly, I want to introduce my project title. My project title is Voice Command Recognition System using SDF, the audio extraction method with CNN model. So let's first talk about my summary of the project. So the summary of my project is I focus on using the short time Fourier transform SDF, the audio extraction method, to extract audio waveforms and then convert into spectrograms. And then using those spectrograms as input for the CNN model. The CNN is a convolution neural network model, and I'll be using those spectrograms to train the CNN model. And there will be 2 datasets that will be used in this project. So there will be a big dataset and a small dataset. And during multiple testing, after multiple testing, I saw that the results with the bigger dataset and more convolutional layer provided like better accuracy and better results. And later, I'll be talking why I started this project, my introduction. So the reason I started this project is because I want to find out how tasks can be made more efficiently and done more easily, so people do not have to type on the keyboard to do an action. Instead, they can just say voice commands in order to execute an action. Furthermore, I also want to research how voice commands can help disabled people who can't really focus on their physical abilities, and how voice commands can help them. Example, people who cannot walk can use why I started my project. So for the method, I've used SDFD for audio extraction method, and then a CNN model for training. So firstly, I use SDFD to extract audio waveforms turn into spectrograms, and those spectrograms I use as inputs for the CNN model for training. And I use 20 epochs for training. 20 epochs basically mean 20 times the model went through the data set in order to learn how to accurately determine the correct voice command. So I use different split ratio as well. So I use 20:80 ratio, 40:60 ratio, and 80:20 ratio. And I also train with and without a convolutional layer, with an extra convolutional layer. Sometimes I added an extra, sometimes I did not add an extra. So there's 2 datasets that I use for my project. Firstly is speech command, a dataset for limited vocabulary speech, and Google Speech Command V2. So these are the 2 datasets that I use. And in the result, I show examples of what results I've obtained in my project. Firstly, this is the waveforms. In the waveform, you can see there's like a small data set for the small data set and the big data set. In the small data set, you can see like I have like go, no, left, voice commands, and these are like in the audio waveforms. So this in the big data set, you can also see there are more voice commands in. And then these are changed into spectrogram using the SDFD method. So you can see this is the spectrogram version of the audio waveforms. And then later, I use them to train in a CNN model. In the CNN model, I provided graphs here. So firstly, I use the accuracy graph. Accuracy graph shows how accuracy improves over time while training. So firstly, let's look at the accuracy graph. In the accuracy graph, after more time, the accuracy improves better. So the more time it undergoes training, the better the accurate results are. And then lastly, I use the loss value. The loss value represents the lower the loss value, the more sure that the model is certain about its outcomes. So if the loss value is going down, it means that the model is more sure of its outcomes. And then lastly here, I have confusion matrix as an example. The confusion matrix shows how well my models can predict the voice commands. For example, let's look at the voice command down. In the voice command down, it accurately predicted 96 times correctly for the voice command down. But there are also certain times, like 13 times, it incorrectly predicted to be go. So it's not the best model, but it is still a good model. So that's I'll tell in the conclusion. In conclusion, I found out that for both data set, I found out that 20:80 ratio split is the best for both data set when you use. So 20% is used for validation and 80% is used for training. And then I use an additional CNN layer, which is better, and it shows better results overall. And then I also noticed that this project was also kind of limited because I didn't use a very good hardware because I was limited by my using my computer. My computer wasn't that good at model training. So these results can also be improved using better hardware and also more data set, so data set containing more voice command. So I found out in a small data set, in my research and my experiment, I found out that 92.7 accuracy. So the small data set had 92.7 accuracy and 0.2 loss value during model training. But then I also did another validation test. In a validation test, it goes through like unknown voice commands, voice commands that hasn't been seen in the dataset. So I used that, and then it showed I obtained 88.8% accuracy and 0.3 in loss value. And then in the big dataset, I found out that after training, the big dataset shows that 90.3 accuracy and then 0.3 loss value. So it's doing pretty well. But I did another test, which is a validation test. In the validation test, for the big dataset, it shows that 89.4 accurate results and then 0.3 in loss value. And then you can do further mock using my research and project. So you can also use it in a smart house system. Let's say you want to turn on the lights or like open the door using voice commands. That can be used in a smart house system. Next, you can also use a voice control wheelchair. Like I said before, for disabled people, you can use voice commands to control the wheelchair to move forward, backwards, or left or right. And then you can also use in a voice-activated security system, where you use your voice to get into a door or something. You use your voice to verify yourself. So lastly, the references that I use. These are important because the first references I use is from NIAC. So they use a Kui language, which is introduced in gaming, and then he kind of used a CNN model that shows that very accurate results. So I was like, I wanted to use CNN model in my own research as well. And the next is the most important. So Kodali, he was a researcher. He found out that he used short time Fourier transform SDFT method, and then he shows that he obtained good results from people who are suffering from dysarthria, which is a disabled people who cannot like talk properly. So it shows good result with SDFT. Therefore, I kind of use SDFT with CNN to see how well it does in a normal situation as well. So this is overall detail of my project, and I want to say thank you for listening. This is my end of my speech. Thank you.